Hi, I'm Andrea and welcome to Productive C Sharp. In this video, I'm going to talk about positional records in C Sharp 9. Writing immutable reference objects with value type semantics has always been very difficult and tedious in C Sharp. With records, this is no longer the case. So let's see the console application that I have at the moment and how I can leverage records to make it a lot more simple. Alright, I have a book class that allows you to create a book with a name, a number of pages, and the language. This class is immutable, that meaning that I can't change the values of the properties after it has been created. Immutability is very important these days because it allows you to write simple code, trace safe, and avoid all the bugs the mutability brings. So, it's something that you probably write already a lot, this sort of code. This code creates few books. Books 4 is created by cloning the book tree and changing the language. Book 2 and book 3 are basically the same, with the same properties. I create a dictionary to count the number of likes for a particular book, and I use the deconstructor to deconstruct a book into a tuple in order to access the specific properties. Okay. Then I'm printing the 3 books, printing the result of using the equality of between book 2 and 3 and book 3 and 4, getting the number of likes for book 1 from the dictionary, and also printing, these individual properties that I've extracted. So if I run this code, you can see that I have the first 3 books printed. Then book 2 is equals to book 3. Even if the book 2 and book 3 are 2 different references, the result of the equality operator is true. This is because this book is not just immutable, but it's also has a value type semantics in terms of equality. The 2 books are equals if all the properties are the same. And that's what we want when we implement a value type. And also 10 is the number of likes for the book 1, and so on. So let's see how you can create an immutable type with a value type semantic using C Sharp. And this is it. You probably wrote this code. You have a book. The book contains 3 init-only properties. You have a constructor that takes the three values and set them in the properties. You have a copy constructor that takes a book and assign the various properties one by one. Get hash code that's required in order to be able to use books inside dictionaries. The equals method, the equals operator, the different operator, a toString to print the representation of your book, and a deconstructor as well. So as you can see, there's a lot of boilerplate code in order to create, this sort of objects. Okay, and this is what records helps with. All right, let's try to change class to records here. As soon as I do that, I don't have to implement IEquotable. I can remove all of this code except the deconstructor that is not automatically created. So let's see if this code still compiles. It doesn't compile because I can't use this copy constructor, but I can use a new syntax called the with expression that allows me to create a clone of an object, book 3, with some particular properties that are different. So book 4 is going to be the same as book 3 with a particular property changed. So this is a new expression that is being introduced in C Sharp now together with records in order to allow this sort of operations. And now I can build and run this code, and it's going to produce exactly the same result as the previous code, but with a lot less code. This is because Microsoft automatically implement the IEquotable of book and all the equality methods for you. Get as code as well, and copy constructors. So you don't need to do it yourself. And you can see that by using JetBrains.pick to decompile the sources and see the actual code that is being generated by the C Sharp compiler. There we go. You can see that IEquotable book has been created. At the end of the day, book is still a class. So records is only a keyword in the C# language, but at runtime is effectively a reference type. There are some properties. The constructor automatically created the deconstructor. There is an implementation of toString that is being implemented by the compiler. Equality methods, getHashCode, and a clone method that is used when you actually use the with expression. So there's quite a lot of code that is being automatically generated by the compiler for you. But you can go further with records. I can remove the entire code here and use this syntax here. String name, int pages, string language. When you do that, this code still compiles. And now you can create an immutable reference object with value type semantics in a single line of code. The way you do it is basically similar to how you define the signature of a function or method, but you use the keyword record before. And then everything has been created for you by the compiler, including the constructor, constructors, and properties as well. This is extremely powerful because now you can write in a single line of code an immutable reference object with a value type equality. And this makes your code a lot more compact, and you finally don't need to write a lot of boilerplate code in order to do this. It's true that there are tools like Visual Studio or Sharper or Rider that helps you to write the implementation of getHashCode and the quality methods and stuff like that, but still you have to maintain that code after it's been generated for you by the IDE or the tool that you're using. With records in C#9, you don't need to worry about that. The code is created by the compiler. You just write a single line of code and you're ready to go. Thank you very much for listening.